Today in Algebra 2 we're going to be working on solving equations. That's Chapter 1, Section 3 in our Algebra 2 book. Starting with the first example, we're going to be solving equations where we have a variable on both sides of the equal sign. The important thing to remember here is to remove the term with the variable from either side by adding or subtracting. Afterwards, it's just a two-step equation, something that we've been doing since Algebra 1 and even before that. So a problem like 13y plus 48 equals 8y minus 47 is asking us to figure out what y is so that the left side balances out to the right. What can y be to make it all the same? In order to figure that out, what we're going to do is isolate the variable by getting it all onto one side, or removing it from one side. So we're going to take away 8y from the right side to get rid of it. I could also have taken away 13y from the left side and then taken away 13y from this side, but then I would have had 8 minus 13. That's a negative number. So it's easier to keep positive numbers. Cross out the 8 and the negative 8y, or the 8 and the minus 8y, because those cancel, and you're left with 13 minus 8, which is 5y, plus 48 equals negative 47. Don't forget that this sign is still here. Even though it's a minus, it's the same as a negative when you have nothing left. It's basically 0 minus 47, which is negative 47. Then it's a two-step equation. We subtract 48 from both sides, cross out the 48. We have 5y equals negative 95, and then divide each side by 5, and we've got y equals negative 19. Negative 19 is the number that will allow the left side to be equal to the right side. So you try. We're going to solve 2t minus 3 equals 9 minus 4t. Is t a, 2, b, 1, c, negative 1, d, 2.5. Go ahead and pause now and try. For more problems like that, you're going to be on page 21, numbers 1 through 8 all. For example 2, we're going to be solving with the distributive property. So remember, you're going to simplify before solving. If you have a bunch of stuff that you can simplify, like on the left side or on the right side, do that first. Some people might try to go 3x minus 7, even though you can't, but the important thing to remember is you always multiply the 7's distributed before you take 3x minus anything. Over here, you got 3 times the quantity negative 2x plus 9, so you're going to distribute the 3 over here. I'm going to do it at the same time to speed things up a little bit. So I'm going to distribute the 7, and I'm going to distribute the 3. So when I do, I get 3x minus 14x minus negative 91, or that's going to turn into plus 91, because you've got a minus and then a minus already. That's a plus. On this side, I got 3 times negative 2x and 3 times 9. Simplifying by combining like terms, 3x minus 14x is negative 11x. Now I'm at the point where I was in the last example, where I have variables on both sides. What should I add to get the variables positive? I should add 11x on both sides. When I do, that cancels out, and negative 6 plus 11 is 5. So I got 91 equals 5x plus 27, and then it's a two-step equation. Subtract 27. Got 64 equals 5x. Divide each side by 5. The answer is 12.8, or 64 over 5 is a valid answer there. So you try. Solve 6 times t minus 2 equals 2 times 9 minus 2t. Is it A, t is 7, b, t is negative 14, c, t is 3, d, t is 3.75. For more problems like that, please do page 21, numbers 9 through 16 all. Next example is a little bit more difficult. We're going to be solving formula. Formula doesn't give you a simple answer because there's going to be lots of different variables, so it doesn't give you just a single number. Instead, your answer actually is going to get more complicated, more messy, but that's okay. That's what we're looking for. You're just trying to solve for a variable. So a few things are a bit different. So let's say we're solving for the area of a trapezoid. So that's a equals 1/2 b plus b. 1/2 h times the quantity b plus b. I couldn't figure out a way to have subnumbers, but basically each trapezoid has 2 bases, and then each trapezoid has a height from one of the bases to the other, and the bases are always the parallel sides. Okay, so what you're going to do is you're going to take the bases and add them together, and then you're going to divide them by 2 and multiply by the height, and that's going to get you the area of that trapezoid. So What we're going to do is we're not going to have any numbers for these. We're going to leave them variables, but we're going to solve for h. That means this is the variable that's going to go by itself. Imagine these are all just numbers. How would you get h by itself if it was 1/2 times h times 5? Well, if you had it that way, you could just divide, because these ones multiplying on the left and the right side. So first, instead of dividing, actually what we're going to do is we're going to multiply by the reciprocal of 1/2. 1/2 times 2 cancels out, and then you got 2 times a on the left side. Now we've got h times b plus b left over. These are both different quantities. If I wanted to get rid of the entire quantity b plus b, I could just divide it away. That's what I'm going to do next. I'm going to divide b plus b on both sides, and remember that b plus b is b1 and b2, and cancel out the right side, and I've got 2a over b plus b on the left side and h on the right side. That's it. You're just solving for the variable. Now if you needed to know what the height of the trapezoid was, and you knew what the area and both bases were, you could figure that out with this formula. So it's useful to be able to convert formulas around, be able to use them quicker, instead of having to plug in all those numbers up here and solve for h up here, even though it's somewhat this similar. So you try. Solve the same formula for b. It could be a, b minus parentheses 2a over h, b, 2a over h minus b, c, 2a minus b all over h, or d, b minus 2a should be the quantity 2a over h. For more problems like that, please do page 21, numbers 17 through 22.